This section is called implicit differentiation. When we say something like the derivative of 5x to the third is (15x squared), we're actually skipping the chain rule, because here's how we really find the derivative of 5x to the third. There's really 4 steps. Step 1, 3 times 5. Step 2, copy what's in the parentheses. Don't really need parentheses here, but I need to say those words. Copy what's in the parentheses. Step 2. Step 3, make the 3 exponent a 2. And the last step is multiply by the derivative of what is in the parentheses with respect to x. So that is the chain rule right there. I'll repeat the steps. 3 times 5, copy, subtract 1, and we have this at the end. That's the derivative of what is in the parentheses. But we usually don't write this dx dx, because dx over dx is 1. That's why we would just say 15x squared. So we're not wrong if we say the derivative of 5x to the third is 15x squared. Don't need to write that. However, the derivative of 5y to the third is, using the same rule, 3 times 5, copy the y, the 3 becomes a 2, and we do multiply by the derivative of what's in the parentheses with respect to x. So that all has to be written down. 15y squared dy dx. Can't leave that out. So implicit differentiation is, for example, page 155, exercise 10. X to the third plus y to the third equals 18xy. 18xy. That's given, and the directions are to find the derivative of y with respect to x. This is the question. We say we're using implicit differentiation when we do not try to solve this for y. We're not going to try to get y all by itself to equal a function of x. We could try to do this, and then find the derivative of y with respect to x. But if we don't do this, we say we're differentiating implicitly. That just means differentiate each term, term by term. So we'll start with x cubed. I'm going to put a 1 here and parentheses around the x. The derivative of 1x to the third is 3x to the second times the derivative of what's in those parentheses with respect to x. I didn't need to write dx over dx, so if you don't write it, it's okay. After the plus, I'm going to put a 1 here, parentheses around the y. The derivative of 1y to the third is 3 times 1 times y to the second times the derivative of what's in the parentheses with respect to x. The other side of the equal sign is a product, and the derivative of a product is always the first times the derivative of the second plus the second times the derivative of the first. The first is red, the second is green. The derivative of a product is the first times, watch this, the derivative of the second. The green here is the derivative of the green, plus the second times the derivative of the first. The derivative of 18x is 18. But I want to make something really clear. The derivative of 18x is actually 18 times the derivative of x with respect to x. So yes, we would just write 18 there. So now this equation, which we got by differentiating term by term, this is the derivative of the first term in the given, this is the derivative of the second term, and all this red and green and red is the derivative of 18xy. Now, we write the equal sign. Well, first I'm going to rewrite this without the dx, because usually I wouldn't write that. dy dx, I have to write that. dy dx, I have to write that. But this last term here, we would write that as just 18y. No need to write dx over dx. Same over here. So now I write the equal sign. I write every term that has dy dx on one side of the equal sign. I write every term that does not have dy dx on the other side. So there's 4 terms in this line. There's still 4 terms here, but every term that has dy dx, this one and this one, those are all the terms that have dy dx. They're on the left side of the equal sign. All the terms that do not have dy dx, this one and this one, all of those terms do not have dy dx. They're all on the right side of the equal sign. The 3x squared had to become a minus 3x squared. Positive 18y is still positive 18y. The positive 18x dy dx is becoming a negative 18x dy dx. This 3y squared dy dx, positive, still positive here. So now, all of these are terms that have dy dx, so factor out dy dx. Factor it out. Copy everything else. So because all of these terms have dy dx, we can factor it out. Distribute this back to make sure it equals what's above it. And one more step, divide both sides by the stuff in the parentheses. I said divide both sides of the equal sign by the stuff in this parentheses over here. So on the right side we have whatever was there, divided by what's in the parentheses over there, 3y squared minus 18x. So we made that cancel on the left side because we divided both sides. And we could reduce that because 18, 3, and 18 are all divisible by 3. So the answer reduced to lowest terms is 6y minus 1x squared over 1y squared minus 6x. It cannot be written any more simply. That's the answer. So, next one we're going to do is number 26. Y to the second plus 2y equals 2x plus 1 And this time it says, well, same directions, find the derivative of y with respect to x. That's the question. When we don't try solving for y first and then differentiating, when we don't solve for y first, we call it implicit differentiation. That means differentiate, differentiate, write the equal sign, differentiate, and differentiate. Differentiate means write down the derivative. The derivative of 1y to the second is 2 times y to the first power times the derivative of what's in the parentheses. Notice I snuck parentheses in there. Copy the plus. The derivative of 2 times y is 2 times the derivative of y with respect to x. The derivative of 2y is not just 2. The derivative of 2x is just 2. If you ask me why I'm not doing this the same as that, I would tell you that I am doing it the same way. The derivative of 2y is 2 times the derivative of y. The derivative of 2x is 2 times the derivative of x with respect to x. I'm going to erase that, dx over dx. Don't need it. And then we got a plus, and the derivative of 1 is 0. So differentiating each term. Now we write all the terms with dy dx on one side of the equal sign, all the terms that do not have dy dx on the other side. Okay, we already have that. Then dy dx gets factored out. Of course, this side is just 2. And then we divide both sides by what is in the parentheses. The derivative of y with respect to x is equal to 2 over 2y plus 2. And that is the same, because of all these divisible by 2, we could reduce to 1 over 1y plus 1. Now, we're not done with this exercise because it also asks for the second derivative, the derivative of the derivative. And we could find the derivative of this using the quotient rule. But if we rewrite this as the number 1, the numerator, times y plus 1 raised to the negative 1 exponent, then we don't need to use the quotient rule. We can say the derivative of that, which would be called the second derivative of y with respect to x the second time, is the number up here, negative 1, times the number in front. What's in here gets copied, y plus 1. The negative 1 becomes a negative 2, and we multiply. This is the chain rule. Multiply by the derivative of what's in the parentheses. The derivative of what's inside here is dy dx plus 0. Now, this dy dx that I just wrote has to be replaced with what dy dx equals. The second derivative equals negative 1. This y plus 1 to the negative 2, you could write that as 1 over y plus 1 to the positive 2. And like I just said, that right there gets replaced with what it equals, 1 over y plus 1. So final answer, the second derivative of y with respect to x the second time for exercise 26 is negative 1 times 1 times 1 over, there's a 1 under here, 1 times y plus 1 squared times y plus 1. That's y plus 1 to the third. And I'm going to do one more example on this video, number 34. X times the sine of y, x times the sine of 2y equals y times the cosine of 2x. Well, we are not going to try to solve for y to equal a function of x. We're not going to try to do that. But we're still going to be able to find the derivative of y with respect to x implicitly. That means differentiate each term. There's only two terms here. And then solve for dy dx. The left side of the equal sign is a product. The derivative of a product is the first times the derivative of the second. The derivative of sine 2y is cosine 2y times the derivative of what's in the parentheses. The derivative of 2y is 2 dy dx. Still doing product rule on red and green. Plus the second times the derivative of the first. The first is x. The derivative of x with respect to x is 1. I could have written dx over dx, but that's 1. So all this red and green and red is the derivative of this product. All right, so we're at the equal sign now. The other side of the equal sign is also a product. It's blue and purple. The derivative of a product is the first. Times the derivative of the second. The derivative of cosine 2x is negative sine 2x times the derivative of 2x. That's just 2. Plus the second times the derivative of the first. The first is blue. The derivative of the first is the derivative of y with respect to x. It's not 1 like the red over here. So I'm just going to rewrite everything. But this green, this red and green and green and red is the derivative of the left side, product rule. This blue and purple and purple and blue is the derivative of the right side, also product rule. I'm going to rewrite this. We rearrange the order of this by putting the 2 in the front, then the x, then the cosine 2y, then the dy dx at the end. Does not really matter what order these are in. This just looks nicer. Plus sine 2y times 1, just can write sine 2y, equals this right here. The negative right here, 2, negative 2 goes at the beginning, then this blue y, then sine 2x. After the plus sign, we just copy that like it is. Cosine 2x dy dx. So there are, let's count these. 1, this is all one term here. 1, 2, 3, 4 terms. There's 4 terms. We need every term that has dy dx. Like this term has dy dx. And this term has dy dx. We need all the terms that have dy dx on one side of the equal sign. This first one here gets copied, 2x cosine 2y dy dx. This term coming to the other side of the equal sign will change from positive to negative. Cosine 2x dy dx. So there's the equal sign. Now we need all the other terms on the other side of the equal sign. So this one's already there, the negative 2y sine 2x. And this one does not have dy dx. We need it on the other side of the equal sign. That means we have to change its sign. Here it's positive, so here it will be negative sine 2y. Now that we have all the terms that have dy dx on one side, we factor out the dy dx. Just take it out. What's left? 2x cosine 2y minus cosine 2x. The dy dx that's in both is factored out. The other side gets copied again. Negative 2y sine 2x minus sine 2y. And then we're going to just divide both sides of the equal sign by this stuff inside here. So dy dx all by itself on the left side equals everything that's over here, negative 2y sine 2x minus sine 2y divided by the stuff over here, 2x cosine 2y minus cosine 2x. Now we are going to finish this exercise in class because the directions are to find the lines that are tangent and normal to the curve. So we need this, but that's not the answer to the question. So we'll use this in class to finish this exercise.